We want to take those average value functions that we just looked at constructing and apply those to solve practical business applications. But before we do that, we want to establish how we can use WolframAlpha as a tool to help us quickly evaluate limits so that we can focus just on the results and then applying interpretations to those. In example 3, we want to use WolframAlpha to evaluate this given function as x approaches, in this case, 3 different values. So we'll take a look at how we can do that. We'll start off by typing in limit of our given function. And as we type in these functions, we'll need to pay careful attention to our syntax here. In this case, the numerator had to be in parentheses because we had that quantity squared, but I also put the denominator in a set of parentheses to ensure that WolframAlpha sees that entire expression as being part of the denominator versus just taking the numerator over x squared and then subtracting 4 separately. So we want to make sure we're careful with syntax to get those numerators and denominators separated. And we want to evaluate the limit of this function as x approaches -2. So again, checking this input interpretation will be very important. We want to make sure that this statement matches up with the problem that we think we're trying to solve. So we need to make sure that the form of this function looks correct and that that limit statement is correct. In this case, both are. And we see that that limit would equal 0. For the next example, we want to take the limit as x approaches 0 of that same function. So we already have the function typed in. We just need to update the limit that we're approaching. And in this case, we would generate a limit of -1. In the last example, we want to consider the limit as x approaches +2. So again, the same function, all we need to do is update that value that we're approaching. And we get a statement here that says the two-sided limit does not exist. Then what WolframAlpha will output for us is the limit from the left, which is -∞, the limit from the right, which is +∞, as well as a graphical interpretation of what's going on. So we see that what we have is a vertical asymptote occurring at x equals 2, and the function is headed in different directions on either side of that asymptote. So since we consider the right and left-hand limit, and those are different, that's going to tell us that in this case, the limit does not exist. So what we came up with was a limit of 0, -1, and then since the left and right-hand limits were different from each other, we would say that this last limit does not exist. In example 4, we're looking at considering end behavior, essentially, or half of the end behavior. We're looking at the limit as x approaches infinity. Our process will be similar here. Now we'll need to update the function that we're considering. And so again, I'm going to put both the numerator and denominator in parentheses to ensure that WolframAlpha understands that that entire expression should be in the top or bottom half of that function. So we'll take the limit of this as x approaches infinity. Again, we want to check this input interpretation just to make sure this matches our problem. And in this case, we get 8/3. Now, we're not asked in this example to find the limit as x approaches -∞, but if we were, it would simply be a matter of putting a negative sign or a dash in front of infinity. And then we could evaluate the limit as x approaches -∞, which again in this case is still 8/3. So our limit, or the end behavior on the right-hand side in this case, would be 8/3. One more type of problem that we've considered looking at by hand or evaluating by hand is finding any horizontal and vertical asymptotes for given functions. WolframAlpha can do that for us as well. When we did this by hand, we would have set up different limit statements. But what we can do is something a little bit simpler here, is we can just say find asymptotes. for each of our given functions. So again, being careful with syntax and parentheses there, we want to find any asymptotes for this given function. And what this will tell us is that our function approaches 1, our function value approaches 1 as x approaches both positive and negative infinity. So that's that idea of end behavior, meaning we have a horizontal asymptote of y equals 1. And as x approaches positive, or our function approaches positive and negative infinity, as x approaches both positive and negative 6, since we have that plus or minus symbol there. So what this tells us is that we have a horizontal asymptote at y equals 1 and vertical asymptotes at x equals positive 6 and negative 6. We can do the same thing for our next function. Always got to be careful with the typing here and just make sure everything's getting entered correctly. So in this case, we find that we have a polynomial asymptote, which is something that can be considered, but not something that we're interested in. We don't have a vertical asymptote or a horizontal asymptote, just this polynomial asymptote, but that's not something we're worried about considering. So we would just say no asymptotes exist. And then in part C, we have one last function to consider for asymptotes. Again, this time we're told that there is a horizontal asymptote and a vertical asymptote. As x approaches both positive and negative infinity, our function value approaches 4. So that's our end behavior, which means we have a horizontal asymptote at y equals 4, and x approaches positive and negative infinity from the different directions as x approaches 7. So we don't have that plus or minus. In this case, just a single asymptote occurring at x equals 7. But we're told that our function approaches both positive and negative infinity because it approaches positive or negative infinity from those two different directions. So what we have in this last example is a horizontal asymptote at y equals 4 and a vertical asymptote at x equals positive 7. So again, just using WolframAlpha to generate some results that we've already looked at establishing by hand.